Hi guys, we are going to be talking about the last 3 steps of the scientific method. Share my screen. Okay. So after we stated our hypothesis, we are now going to design and conduct an experiment. So this is step 4. Step 4, design and conduct an experiment. To design an experiment, you need to identify a couple different things. So first you need to identify independent variables. So this is what you want to test or change. So what you want to test or change in your experiment. Dependent variables are what you want to measure. Control group is how will you know the independent variable caused a change in the dependent variable. And then the experimental group tested, all conditions are kept the same except the independent variable. So remember, the independent variable is what you are going to change. All right. The independent variable, so how we were talking about Asian citrus psyllid last week and the application of cyfluthrin. So cyfluthrin is the pesticide that is going to kill the Asian citrus psyllid, supposedly. So that would be the independent variable, application of the cyfluthrin pesticide. The dependent variable is the number of Asian citrus psyllid found on citrus trees, so the number of pests found on those trees. The control group is one group of citrus trees receiving no pesticides. All of the variables remain constant: water, sunlight, oxygen. So the experimental group is the group of trees that are going to get the independent variable, which is the application of cyfluthrin pesticide. So it's receiving the pesticide treatment. And just like the control group, all other variables remain constant: water, sunlight, oxygen in the trees. All right, number 5. So after we figured out all of that, we need to now collect the data. So collect quantitative and qualitative data obtained from the experiment. So quantitative is report in quantity numbers. So International System of Measurement, length in meters, mass in grams, volume in liters, time in seconds, temperature in Celsius degrees. Qualitative is reports as descriptions. So qualitative is the data that cannot be counted. It's usually grouped by characteristics and is subjective information. Quantitative, on the other hand, is data that can be counted, so numbers, and sorted based on numbers. This is objective information. So quantitative is based on numbers. Qualitative is grouped by characteristics. We need to remember those two. So qualitative data, so the tree health, the leaf color, the fruit set, fruit quality. So is the leaf color looking good, or is it looking dull? Something wrong with it. Quantitative is the population of Asian citrus psyllid. So how many Asian citrus psyllids are now on the trees? Is there any? Is there a lot still? And then the population of trees infected with Asian citrus psyllid. Okay, now moving on to the last step, number 6, form a conclusion. So forming a conclusion, decide if your data either supported your hypothesis or it did not. So did the Asian citrus psyllid, did that pesticide cyfluthrin actually work, or did it not? So you can have some experimental errors, so anything that could cause your data to be skewed. So examples are inaccurate measurements, inaccurate data recording, experiment contaminations, unforeseen circumstances, so like loss of power, change in weather. So anything could happen, especially we never know what, well, here in California, we know the weather usually doesn't change much. We don't get much rain. We know that summers are hot, winters are colder, not extremely cold. We don't get snow. But if you live in a place where you don't know what the weather is going to be like, that would be hard. That could, unforeseen circumstances could happen, which can cause inaccurate measurements, inaccurate data recording, anything like that. Forgetting to count a section of trees for the number of Asian citrus psyllid. So that also can be something, if you forget, that could be a big error. So hypothesis supported. This is your conclusion. So I'm going to give you an example of hypothesis supported and hypothesis not supported. So supported, my data supports my hypothesis because the amount of Asian citrus psyllid on the trees treated with cyfluthrin decreased compared to the control group. Hypothesis not supported. My data does not support my hypothesis because the amount of Asian citrus psyllid on the trees treated with cyfluthrin had no effect on the pest population. Areas of experimental error included miscalculated application rate. So this right here states that trees treated with cyfluthrin had no effect on the pest population. Areas of experimental error include miscalculated application rate. So miscalculations could cause errors, guys. Okay, we are done with the 6 steps of the scientific method. So I hope that this helped you guys so you guys can take notes in your ag bio notebook. Yeah, so thank you guys.